So in this case, we are going to consider as a continuation, now working with the reflection in axis. As we consider the reflections, they can happen along any line, along any line. But in our case, we are working only on the axis, meaning to say we are referring to the x-axis and to the y-axis. Those are the two axes that we are going to consider. So a reflection, guys, it is an easier concept. You just consider how you view on a mirror. Let's say you put a mirror here. You will find out that when the object is on this point, on this side of the mirror line, all right? So here, this is our mirror line. This is the concept of a reflection. When the object is on a certain position or certain side of the mirror line, this is the other side of the mirror. And we also have this side of the mirror. When the object is on one side, the image will be found on the other side. So that is where our image is going to be, on the other side. For a vertical line as we are working with, meaning to say for the y-axis, for a vertical line, which is our y-axis, it is going to be a horizontal distance between between the points that is formed. The point will actually be moving horizontally. And in that case, the distance that the point moves to the mirror line, which is our y-axis in our case, the distance that it moves, the distance here, if it is a units, it is going to move the same distance to the other side of the mirror. So if it moved 5 units, it is going to also move 5 units there. So if it moved A, this is going to be A, the units that was moved. This is the condition of the mirror line considering a vertical. So what is it that we actually can see from this part? If a point is being reflected because it moved the same distance and then same distance to the other side, what we are simply doing here is neutralizing the value of x. If our x, let's say it's -3, when you move 3 units to the y-axis, it means you are now at the what? At the origin at 0. So you move 3 units to the other side, so the x value is simply going to change to positive. Guys, take a consideration. This is your y-axis here. This is your y-axis. You are focusing on the y-axis. So if a point is here, the number of units that you move to the y-axis is neutralizing to the origin. Then you move the same number of units. If it is 1, 2, you do the same thing on the other side. So it is just changing to say maybe it's -3. The point will change to +3 because you neutralized to the origin, then from the origin to the image. So it will be a positive. But remember, guys, this is horizontally formed. I mean, the distance there, we are forming a horizontal line where we understand that the y value is not going to change. If y is equal to a, it's going to be a. If y is equal to 2, it's going to remain as 2. The y value is not going to change. It is going to remain the same. What is affected is the x value. The y is not. So are we seeing that if we have a value of x, we simply have to multiply a negative? It changed from -3 to +3. The y is not affected. It is the same thing even when you reflect across or along the x-axis. You have got a point here, then its image will be here. Same distance to the x-axis, same distance to the image. So what you're simply doing in this case is neutralizing the points as you are moving to the what? As you are moving to the x-axis. But what is formed? Horizontal line, where the x value does not change. So it is the y value that is going to change. If there is a y value here, the moment you move to the other side, the number of units, then you moved on top. If it was minus, then here it's going to be a positive, but x is not affected. Here, the same. X was affected, but y is not. Y is not affected. So these are the effects. So meaning to say, when it is along the x-axis, when a point is given as xy, since x is not affected, it is going to remain as it is, but the y value has to change to a negative. That is the condition when dealing with points. The reflection along the axis, all right? So let us have these in form of points and also in form of what? Functions. Remember, you can reflect a point, you can reflect the whole graph that you are given, all right? So as we are considering a reflection in the x-axis, let's start with x-axis. In the what? In the x-axis. So in the x-axis, if you are given f of x is going to change, all right? Along the x-axis, your f of x, if it was like this, we are going to see that on the other side this way, yeah, on the negative values. Remember what I said? If this is your mirror line, one shape is on the other side of the mirror, other one on the other side of the mirror. So this is on the positive side. We are going to have the other one on the negative side. So simply our f of x will change to minus f of x. You simply have to multiply your f of x by what? By a negative. But as of the points, we saw that when we are dealing with the x-axis as of the points, all right, this is what we saw as of the points. If I am given the point xy like this, it is going to change to the x is not affected. It remains the same, but the y value is the one that is affected. It changes to a negative. So you multiply the y value by a negative. That is, the y value changes the sign. So this is a reflection that we are simply talking about, guys. A reflection in the what? In the x-axis. All right, which is opposed to the one for the y-axis. So in the y-axis, we are going to notice our f of x this time is going to change to be written to as f of minus x. So it will be f of minus x, like this. The x value, remember, it is the one that is affected. It changes to a negative. Let's explain in terms of the points. Remember, it is like this. X, y, then we changed to say the y value is not affected. It is the x that is affected. So the x changes to a negative. So this is the f of what? The f of minus x that we are having there. So that is minus x. The y value is not affected. So that is it. That is the concept. A reflection which occurs in the what? In the y-axis. X is affected. In x-axis, y is affected. So this is how you can attempt your questions. Just like the previous case where we are given points or when we are given it as a function, it is just one and the same. So let us just consider one or two of the examples how these questions can actually be given as. All right, so let's say we are given a function of f of x. So we are going to consider, as there are two reflections, guys, let us just consider them into two, like reflection. Let us start with the x-axis, reflection in the x-axis. So as of the reflection in the x-axis, what I'm simply saying is that all the questions that you're going to have for now, we are going to reflect everything, a point, a function in the what? In the x-axis, all right? So let us say we've got a function, y is equal to x squared plus 3. When it is being transformed, or when it is being reflected in the x-axis, we saw that the presentation of our f of x is going to change. All right, this is minus f of x, all right, from what we have here in the x-axis, minus what? F of x. This is a function, so we must have it as minus f of x. Simply take your f of x as it is. This is your f of x. Multiply it by what? By a negative. The whole part of your f of x. So meaning to say we are going to have our image as minus. We put our f of x as it is. X squared plus what? Plus 3. So that is the answer that you have. Yes, you can even expand this one. So that is going to give us minus times x squared. That's minus x squared minus what? Minus 3. Minus f of x. When it is a point, let's say we have got a point 4 minus 2. A reflection in the x-axis, we saw the concept, guys, that the 4 minus 2 is going to change on a way that the y value is the one that is affected. Multiplied by what? By a negative. The x value is not affected. Why there? Changes to a negative, or you multiply it by what? By a negative. So we are going to have our x value as it is, which is what? Which is 4. But the y value, we are going to multiply it by what? By a negative. We have transformed this in the x-axis. So that is going to be 4 minus minus. That's what? That's a positive. So this is what we are going to have on our image, or as the image point of what? Of 4 minus 2. Given the function f of x, another one, we can be given y is equal to the square root of x. So just like before, y is equal to what? In the x-axis, minus f of x. So simply take your f of x, then you what? You multiply it by what? You multiply it by a negative. This is our f of x. The whole part under the square root. So it's minus the square root of x, which is simply a minus square root of x that we are having there. Just like that. So it can be any function, it can be anything, guys. Just multiply by the negative. You are given f of x, which is given as 2 to the exponent of x minus 1. In order for us to reflect this, y is going to change, which is going to be minus what? Minus f of x. So the image will be minus f of x, this part as it is. This is your f of x. So that's 2 to the exponent of x minus 1, which you can leave it as it is, or you can expand by the negative. So that is going to give us what? Negative times this, that's negative 2 to the exponent of x. Negative times negative, that's a positive 1. So you can even just write it as 1 minus 2 to the exponent of x. This is how you can have your transformations as. All right, let's consider another part. In the y-axis, we can also have conditions where this is in the what? In the y-axis. So in the y-axis, remember the effect that we are going to have for the given function and for the points, all right? Given a function f of x, it is going to be given as f of minus x. As of the points, the x value this time is what is affected. We are going to have our x value affected, x to minus x. That is the condition when we are having in the y-axis. All right, so let us consider the first example. Let us say we are given y is equal to x cubed minus 2. A reflection that's going to happen in the y-axis. What are we going to have? As we said, y is going to change to f of minus x in the y-axis. Remember this concept f of, substitute that f of what? Minus x. In place of x, put that minus x. So meaning to say where we see the x is going to be minus x to the exponent of what? Of 3. Minus 2. This is our transformed function, of which we can even expand this. Minus to the exponent of an odd number remains as a negative x to the exponent of what? Of 3. Minus 2. So this is what you're going to have after the reflection. So you must be very careful how to attempt these typical questions. Also in the y-axis, let's say we have got a point 5 minus 7. What is going to be its image? What is the condition? X is the one that is affected, changes. Meaning to say, for the point 5 minus 7, our x value is going to be affected with a negative. So it's going to be negative 5, but the y value is not affected, remains as it is. So this is xy, then we've got minus x, y. Just like that. A point is transformed there. We can have a point again, let's say minus 8, 3. So given minus 8, 3, it is going to transform its image along the y-axis. Remember, is the x value that is affected. We need minus x here. The x minus, what is our x? Our x is what? Is minus 8. The y value remains as it is. So meaning to say this is going to change to minus, minus, that's what? That's a positive. So this is going to be our image after a reflection in the what? In the y-axis. So this can be on any graph, any point. Whether you are given an exponential function y is equal to e to the exponent of x, it can be reflected in the y-axis using the same concept or the same manner to say this will be what? F of minus x. Once we understand that, we are done. Once we understand that concept, we are done. For a function, for a line, whether it is a hyperbola, whether it is a parabola, whatever that you're given. So in place of x, simply put what? Minus x there. So whether the question now can say your answer as a positive exponent, now you simplify, this is same as 1 over what? E to the exponent of x from our exponents. But here we already have the solution. You attempt now, or you answer the question according to how you are given it. The question. They can combine these transformations. The reflection in the axis. Remember the others that we dealt with, the horizontal shift and the vertical shift. So it can be a combination. We are going to look into those typical exam questions where they can combine 2 or 3 transformations. You must be very careful how the question is given. This transformation, is it followed by this, or it is just a transformation that is given? But all these, you must be able to follow them, all right? So we are going to meet again, working with other transformations that we still have in our syllabus. So like I said before, make sure that you become part of the members so that you do not miss any of the other classes that we are going to have on our revision for mathematics grade 12.